Derivatives and rates of change, Part 2. Recall that the tangent line to the curve y is equal to f of x at the point a f of a is the line through P with the slope m is equal to, and then we have two different definitions we can use here. The one that is preferred by most people is the one with the h. So the limit as h approaches 0 of f of x plus h minus f of x all over h. And this is because the simplification for this one typically requires you to factor in some way. And the simplification for this guy typically requires you to expand. And most people are a little bit better at expanding than they are factoring, simply because we learn how to expand before we learn how to factor. So most people have more practice with it. For this video, I'll go through both definitions, but in general, you're going to see me use this definition for a problem. So this asks us to find the equation of the tangent line. And actually, let me just box that whole thing. Equation of the tangent line. So anytime you're asked to find the equation of a line, that means you probably want to use that y minus y1 is equal to m times x minus x1, so the point-slope form of a linear equation. And we know that the slope of a tangent line, m, and I guess I don't have much room here. Here we go. Where m is equal to f prime of whatever point we're interested in. So that means that we need a point and we need a slope. So let's do that for this one. So we have f of x is equal to x squared minus 2x plus 4 at x is equal to -1. One of the first things I like to do is to find my point. So right now my goal is to find my x1, y1. Keep confusing my subscripts and my commas. Here we go. We are given x is equal to -1, so we can substitute that into our function. So f of 1 will be equal to, f of -1 will be equal to -1 squared minus 2 times -1 plus 4. So that's 1 plus 2 plus 4, which is equal to 7. And that's the output, so that's my y1. So my point is -1, 7. So that means that so far, I have y minus 7 is equal to m times x minus -1, so plus 1. And what we need to find is this m, which will be f prime of -1, so the derivative of our function at -1. So let's start finding our slope now. So we have that m will be equal to f prime of x. And that's equal to the limit as h approaches 0, because I'm going to start with the definition I prefer, of f of x plus h minus f of x all over h. And eventually we'll want to find that at -1. But for now, let's just find our general derivative. So let's substitute that in. So if you have f of x plus h, that means anywhere we see an x, we're substituting in an x plus h. Because you don't have to substitute just a number, you can substitute anything that's in a function's domain into it. Visually, we could substitute shapes if we felt like it. So this will be the limit as h approaches 0 of x plus h squared minus 2 times x plus h plus 4 minus f of x, so minus x squared minus 2x plus 4 all over h. And then we'll need to do a bit of simplification. I've scooted this up to try to give myself enough room for this limit, so let's see what happens. So we have the limit as h approaches 0 of, well, let's expand and distribute each of these. So the limit as h approaches 0 of x plus h all squared will give us x squared plus 2hx plus h squared. Then we can distribute this minus 2, so we have minus 2x minus 2h, and then this lonely plus 4. And then we can distribute this minus sign to this minus sign to each term in the parentheses. So we have minus x squared plus 2x minus 4 all over h. And now, as will frequently happen with this process, we have a bunch of terms that we'll subtract out. So we have an x squared minus x squared, a minus 2x plus 2x, a plus 4 minus 4, which I'll subtract out to 0. And that leaves us with the limit as h approaches 0 of 2hx plus h squared minus 2h all over h. And now each term in the numerator has an h, so we can factor that h out. So this is equal to the limit as h approaches 0 of h times 2x plus h minus 2 all over h. And now we have h's that divide out in our numerator and denominator. And I can divide them out using different colors. Oop, that's a little difficult to see. We'll see. We'll divide out with yellow this time. Which leaves us with the limit as h approaches 0 of 2x plus h minus 2. And now this is the limit as h approaches 0, which means that nothing is happening to our x's. We're only worried about what is going on with our h's. So we have 2x minus 2, or rather 2x plus 0 minus 2, doing some simplification in my head, apologies, which then leaves us with 2x minus 2. And this isn't our final answer, but it does give us that f prime of x, which is that slope in general. So all that's left now is to find that slope specifically at x is equal to -1. So we found our derivative, that m is equal to f prime of x, which is equal to 2x minus 2. Now we just need to find the specific slope at x is equal to -1. So that'll be f prime of -1, which is equal to 2 times -1 minus 2, which is -4. So for overall, if we're finding the equation of the tangent line, we have y minus 7 is equal to -4 times x plus 1. And this would be the equation of the tangent line in point-slope form. You could also distribute, then add 7 to both sides to find the equation in slope-intercept form. So just be careful, read the question. Is it specifying which type of equation they want you to have? Now for the other definition that usually isn't quite as nice to use, but you might like it anyway. So we've gone back to the point in the problem where we found our y2, but still need to find the slope. So we need to find f prime of -1. Now, in order to find the equation of a tangent line to a given curve at a point, we have to be a little more careful if we're using the other definition. So we have the limit as x approaches a of f of x minus f of a all over x minus a. And when we're using this definition, we actually need to find the specific point here. So we actually have to find our f prime of -1. So the limit as x approaches -1 of f of x minus f of -1 over x minus -1. If we just leave them as a's, the simplification becomes terrible. You don't want to do it that way. So this will be equal to the limit as x approaches -1 of f of x, so that's x squared minus 2x plus 4. And at this point in the problem, we've already found f of -1. It's 7. If you don't remember, we just found that by substituting -1 into our function. So we have minus f of -1, so minus 7, all over x minus -1, which is x plus 1. And then we'll need to simplify a little bit. So this will be equal to the limit as x approaches -1 of x squared minus 2x plus 4 minus 7, so that'll be minus 3 over x plus 1. And now we'll need to factor. So we have the limit as x approaches -1 of, well, our numerator factors to x plus 1 times x minus 3. And this is all over x plus 1. So these entire x plus 1 factors will divide out. And we have the limit as x approaches -1 of x minus 3. And now we can use direct substitution. So we have -1 minus 3, which is equal to -4. And that is the m that we need. So we still get y minus 7 is equal to -4 times x plus 1. And this definition will work as long as you're actually given a number for our x. If you just have x is equal to a, this can be a very difficult definition to use. Otherwise, if you're pretty good at factoring, it's not all that bad.